Mm. Hello guys, I'm so glad to share with you my idea. It's a nutrition management project, and so for this nutrition management project, it's going to deal with malnutrition problems like poor nutrition. Poor nutrition, it comes as a result of not eating food with good nutrients like carbohydrates, proteins, ions, vitamins. So as a result of deficiency of these food values, you're bound to face deficiency diseases like anemia, obesity, heart disease, and so on. So it has come into our concern because most people have lost their lives due to these deficiency diseases, especially the infants. As we go on, so the question is, how does the AI or the artificial intelligence involved in this project? So through deep learning, the AI algorithms that can store health records of a person and identify the different food nutrients. So in this AI, in the AI involvement here, we are bound to develop a system that is able to identify a person's health, like the deficiency, through even comparing with the health records of the person. And also the system should be able to scan the food samples and tell the food nutrients or values present in those food samples. And at the end of the day, this system should be able to recommend the person to the necessary food samples that contain the needed food values. The data types to be used in this project are majorly image data type and the text data type. The text data type, we are to feed in the person's names, the person's health records, and even the different food values of food samples available. And the image data type, we have to feed in the system images of the person and the food samples available so that the system can diagnose the given food samples. So here we are going to look at the differences between supervised learning and unsupervised learning. So supervised learning here, it relies on labeled inputs and output training data, which is not the case for the unsupervised learning. Um, its number of classes are known, whereas the number of classes of unsupervised learning are not known. It's complex because in supervised learning, we carry out different comparisons, computations, verifying stuff. Is this valid? So whereby it will become very complex at the end of the day. Of which the unsupervised learning does not necessarily mean the less computation and complexity. Like, doesn't necessarily need computations, just so thereby, at the end of that day, you'll find that the supervised learning will have accurate and reliable results, which is not the case for the unsupervised learning. As we go on, so as far as we are concerned, the supervised learning techniques that are going to be involved in this project are majorly regression and classification. For the case of regression, we are going to use majorly the logic regression, whereby the system will be able to examine the various characteristics of the food nutrients, comparing them, like as it's a way of sorting them and like following the given characteristics. Does this food have this color? Does it have these characteristics? Is it a grain food? Is it a cereal? So most cases back then in our school, we used to know that cereals majorly contain proteins, you get, or starch. So it will be able to give you an answer and be like, the food is, yes, it's okay to be consumed. It also gives you the results that after consuming this food, proteins will be added to your body. Secondly, the classification, it involves use of decision trees. So many of you know decision trees. Decision trees are majorly a logic way. It's a logic diagram that follows on the necessary outcomes of a given statement. So For example, you can be like animals. Then you say short or small. Short, I mean short or tall, small or big, as that, wild or domestic. So at the end of the day, this system we are developing, it's supposed to be able to identify like different food values in the given food samples. So also in AI, we are having two learning techniques, the supervised and unsupervised. So for the unsupervised learning techniques, we are going to use the probabilistic technique. Many of you are a fami- a fami- a fa- Many of you are familiar with probability. So the probabilistic technique, it involves use of probability rules. You know, probability refers to the number of chances. It refers to the number of chances that are to be the number of chances for the presence of these given food values. So it will be able to tell you that this food is certain to contain food nutrients like this and that. So we have the algorithm technique. So this system determines that it's supposed to be able to determine the food samples with the same food nutrients that are required. So it will go on comparing given food samples having similarities, and therefore it will be able to give you a list of the recommendations, a list giving you food samples that are suitable for your body. Next, like any other project, we are bound to face technical challenges. First and foremost, there is the bias problem, and this majorly involves that the system may lack data regarding different food nutrients or other unknown components. And infrastructures, so most projects or most systems are built on outdated infrastructure, and it may be due to high expenses. Most developers can't afford the given infrastructures. Thirdly and lastly, explainability. So our system may not be able to deal with the inbuilt algorithms in order to make appropriate decisions. Um, like any other problem, these problems also have solutions. The bias problem can be solved by developing easily explained algorithms that can easily be read and interpreted by the system. Infrastructure simply the developers should carry out thorough background checkups or surveys, and maybe budgeting plans through meeting up with corporations for investment. There is the explainability problem, which can be overcome by implementing algorithms that enable the system to provide transparent decisions. Wow, so accuracy, recall, precision, and F1 score. Accuracy simply is the number of correctly predicted data points out of all the data points. So it can give you the answers that you correctly predicted for a given outcome. Then recall, this is a measure of how many relevant elements were detected. So we have also precision. This refers to the number of true positives divided by the number of predicted positives. So many of you may be like, what is the difference between true positives and false positives? We have also true negatives and false negatives. So the difference is for the true positives, you can do what? You can predict the chances of success of this system. It can be like 5 out of 10. And if the system, yes, really comes out with a 5 out of 10, that's a true positive because it is in line with with something you predicted. And for a false positive, it doesn't come out in line with what you predicted. We have the F1 score, is a performance metric for classification. AI evaluation metrics are majorly the ones I've explained before, but these ones are majorly the ones we are going to use in this project. So we have the F1 score and we have the classification accuracy. F1 score, this one will majorly tell us how precise and robust our classifier is. And by precise, I mean to be able to tell the instances involved in the project. As we go on, winding up this beautiful session, these are just links and they can really help you to get more knowledge about what I'm telling you right now, and you can get further knowledge. So thank you guys, stay safe, and don't forget to like and subscribe, or you can comment anywhere you've not understood. I can be in line to help you. Thank you so much.